Hello, ndikulandireni kuphunziro lathu lalero pamene tikufuna kupitiriza trigonometry 2 imene imaphunzitsidwa mu form 4 ndipo lero tipanga area rule of a triangle mu lesson 4. Muli ndine Sisalo Juma. Mbuyomu mwakhala mukupeza ma area of a given triangle. That is when you know the height of that triangle. Today we are going to look at scenarios whereby you do not know the height of that given triangle. And if you do not know the height of a given triangle, it's easy to use the trigonometry to find the area of that triangle without even being given that height. So in this lesson, we are going to use the area rule to find solutions of that nature. So dwell much on how the area rule came about in this lesson. Then we'll look at two examples, maybe one example, just to make sure you understand the concept. Now, tipange derive area rule. So for us to derive that area rule, let us consider this triangle. So that triangle A, B, C. Remember, that's how we label them. Okay. Then, since we have this triangle where we only know my side here. We may know one of the angles, but we don't have a height. So for us to find the area of this triangle, we need to know the height. And that height has to be perpendicular to the base. In this case, our base is BC. AC, that's our base. So let's say that's height. So our duty here is to find the value of that height. Remember, we have area of triangle, area of a triangle to be equal to half base times height. Height, we don't know. That's what we need to find. So let's find that height. But in this case, we are going to use trigonometric ratios. For us to find the height. Here we are dealing with a triangle which we do not know the height. So we want to find that height by using trigonometry to find it. So for us to find that edge, we can either consider, let's say that point D, we can either consider one of the triangles, whether BDC or ABD. In this case, consider triangle BDC. In triangle BDC, if we are to find H, that's height, we consider that angle C. You find out that H is opposite. DC we don't know, but we know hypotenuse. So we can use which means we are going to say sine angle C is equal to opposite, which is H, over hypotenuse, which is A. Okay, which means our H will be equal to A sine angle C. Okay, I hope we are together reaching that far. Okay, so we already know that the area of a triangle, in this case, let's now consider triangle. Okay, let's just take that out. We know that. Now let us find area Okay, let's consider now area of that triangle BDC, because the triangle that we are considering. Okay, so this one, we know that it's half base times height, and the h tamupesa. So we are just going to substitute. So it will be equal to half b. Where there is h, we are going to put a sine c. A sine c. Okay. Let's get to that. So the area of that triangle, that is, if we remove h now, its area will be half base sine half b a sine c. Okay. Alternatively, we can also find it as, we may consider this angle. Okay, we may consider that angle, which means to say that we already know h. In this case, should be ABC. ABC, not that, because we are considering now the whole, B the whole. Yeah. So alternatively, area ABC could be used considering that angle now. Okay, if we are to find that angle, okay, let's just say half base times height. So now considering that angle, for us to find h, you find out that in that scenario, let's say consider triangle ABD. Consider triangle ABD. Then in that triangle ABD, you will see that sine angle A will be equal to opposite, which is h, times hypotenuse, over, so opposite over hypotenuse, which is c. So for you to have h will be equal to c sine angle A. So for us to now to find the total area of that, you will find out that therefore area will be equal to half B, where there is h, put this one, C sine angle A. C sine angle A. So this triangle, its area can be found by using Akula. That is, if you know angle C, you just have to use, if you know angle C, so you consider A and B. Okay, if you know A, B, and angle C, you can find the area of that. Alternatively, we have also shown that the same area can be found, that is, if we know angle A and you know B and C. Okay, alternatively, the same can be done to if we know angle B. It means if you know angle B, you have to know C and A. Therefore, we can happily conclude that area of let me just draw the triangle here so that equals A, B, C. Okay, area, so this is A, that is C, this is B. Okay, so area of A, B, C can be found using these three formulas. Okay, number one is half B, C, but it should be sine A. We have already shown that. Or half, in that case, if we know that angle B, then it will be half A, C, sine angle B. Okay, or can be found using half, that is, if you know now that angle C, A, B, okay, if you know that angle to be A, B, sine angle C. How we did that? We have proved. We do this. Please do not memorize these formulas. You just have to know zimene akupatsana. Zimene akupatsana izo, you should understand. Kuti zimene andipatsazi, the formula that I need to use, ndiyakuti. Let's look at that example. In this example, they're saying find the area of A, B, C. This is a triangle, but this triangle is not a right-angled triangle. Okay, here they have just indicated that this BA is 7, AC, these ones are indicating that that line and that line are equal, which means this is an isosceles triangle. It's an isosceles triangle, which means this side is also 7. So being an isosceles triangle, that angle has to be 50 as well. These angles of an isosceles triangle are equal. That's the first step for this. So if you know that, remember, you can know that angle. If you know that angle, it means if you consider angle sum of a triangle, it's 180 minus 50 plus 50, which means this angle is 80 degrees. Now we know C we know B, and we know the angle in between. So for us to find the area of this one, it's simple. You just say half. In this case, we are considering that we know that angle, and we have those two sides. It will be half CB sine angle A, which will be equal to half times C is 7 times B is also 7 times sine 80. That should give you an answer. Okay. It's simple. A little bit, what do we know this side? Tunataviuza here, kapena that one. So let's solve that one. So if you punch that into your calculator, it's 24 square, whether it's if it was in meter, then it's going to be square meters. That's the area of that triangle. All right. Let's try to look at this other example. Okay, in this one, they're saying we have that triangle DEF. So they're saying show the area of triangle DEF to be half DF sine A. Okay, so we have that D, it means this one is D, this one is small f, this one is A. Okay, so the issue is to find the area of that triangle. Okay, for us to find DF sine A, we need to find means of knowing that one. Okay, because remember in this case, yeah, so we try to extend that one so that we should have something like a right angle somewhere. Yeah, a right angle somewhere. So let's label this one as maybe H. Okay, so we may consider and that should be H. We may consider triangle DHE to help us find F. Okay, so for us to find F, we can say that we can consider the same thing. Sine, in this case, we are considering that triangle. DHE, we consider that angle, sine E should be equal to opposite, which is H, over hypotenuse, which is F. Okay, so in this case, H will be equal to, that height will be equal to F sine A. Okay, sine angle A. Yeah, so remember our the area of finding a triangle is half base times height. In this case, this is our base D, and we have found our height to be F sine A. F sine A, that's our height. Okay, so So the area of this one, it's a half base times height. So area will be equal to area of DEF is equal to half base, should be half base times height. And our base, let's go there. Our base, remember our base is D. Half, so we'll put D. Our height we have found to be F sine angle A. So if you look at that, indeed, the area of that triangle is that one, half DF sine A, which is that one. Thank you. Let's meet again next time when we come again with another lesson.